In the Carboniferous forests, not everything was as simple as it seemed. At first glance, many plants looked like ferns, with large, divided fronds spreading across the landscape. But among them was a group that quietly rewrote the rules of plant evolution. These were the seed ferns, known to science as pteridosperms. Seed ferns resembled true ferns in their appearance, with their lush, leafy fronds dominating the undergrowth and forest edges. But hidden among their foliage was a revolutionary feature: they didn't rely on spores for reproduction. Instead, they produced seeds. It was a subtle change, but one with massive evolutionary consequences. Spores, used by true ferns and mosses, worked well in wet environments. But they were vulnerable. Spores needed constant moisture to survive and grow, limiting where plants could spread. Seeds, on the other hand, offered protection. They carried a tiny plant embryo, wrapped safely in a hard outer shell, along with stored food to support early growth. With seeds, plants could survive in drier areas, away from swamps and bogs. This small advantage allowed seedy ferns to colonize new environments that were out of reach for their spore-producing relatives. In parts of the Carboniferous world where the climate fluctuated or soil drained quickly, seed ferns thrived, pushing the boundaries of plant life beyond the damp, shadowy swamps. Unlike modern seed plants such as conifers or flowering plants, seed ferns weren't towering giants or forest rulers. Many grew as small shrubs or bushy plants, covering open ground, rocky areas, and forest edges. But their presence marked a critical turning point. They were among the first plants to combine fern-like foliage with the evolutionary leap of seed production. Over time, this innovation reshaped ecosystems. As climates dried and swamps retreated near the end of the Carboniferous, groups like seed ferns and early conifers gained the upper hand. True ferns remained, but the dominance of seed-bearing plants had begun. Seed ferns themselves would eventually fade from the world, replaced by more advanced seed plants. But for millions of years, they played a vital role, bridging the gap between ancient, water-dependent vegetation and the rise of plants that could truly conquer land. In their fossils, we see a glimpse of this transition, a time when forests weren't just growing taller, but smarter. When evolution didn't just favor size, but innovation hidden within a single seed.